The Big Lie About Dark Energy, A New Look at Time. You can find a link to the paper RTD-EU below in the description. Chapter 1, A Broken Universe. Imagine you're staring into the night sky, billions of stars, galaxies, ancient light. Now imagine that everything we've been told about the universe's fate might be wrong. In 1998, something happened that shook the foundation of cosmology. Astronomers looking at distant supernovae made a shocking discovery. These exploding stars were dimmer than expected. The implication? The universe was not just expanding, it was accelerating. Something unseen, something powerful, was pushing galaxies apart faster and faster. And so we gave it a name, dark energy. But what if we misunderstood what we were seeing? This video will take you on a journey through space, time, and perception. If you're fascinated by science, truth, and challenging assumptions, like, subscribe, and stay with me to the end, because I'm going to show you a different way to look at the cosmos, a way that could explain everything without dark energy at all. Chapter 2. The Foundation of the Mystery. To understand this mystery, we have to go back, not just to 1998, but to Einstein. Einstein's theory of relativity told us that time is not absolute. Time bends with gravity. Time stretches with speed. Time is relative to the observer. This is not just abstract theory, it's tested every day. Our GPS satellites orbiting Earth must account for time dilation or their signals drift. Time moves slightly faster in orbit than it does on Earth. That's relativity. Proven, measurable. But here's the twist. When we look across the universe, across billions of light years, we forget this. We assume that time is flowing the same way everywhere. That a galaxy 10 billion light years away experiences time like we do. But why would it? Chapter 3. The key idea. Time across an expanding cosmos. Now imagine this. The universe isn't just expanding in space, it's expanding in time. As space stretches, the flow of time for distant regions of the universe also stretches. Galaxies far away aren't just farther in space. They are existing in slower-running time frames. So when we see light from a distant supernova, we're not just seeing a light that traveled far. We're seeing light that came from a place where time itself was flowing differently, slower. The result? The light takes longer to reach us. It appears dimmer, and we think the expansion is accelerating. But maybe it's not. Chapter 4. The Theory. RTD-EU. This brings us to a new theory. Relativistic Time Dilation in an Expanding Universe. RTD-EU for short. It says that what we interpret as accelerating expansion might simply be a relativistic effect of cosmic time dilation. The further away a galaxy is, the more its local frame of time has been stretched by expansion. This effect is subtle, but over billions of light years it becomes enormous. So we look back and we see dimmer supernovae. But we're not seeing acceleration. We're seeing different time zones of the universe. The age of the universe may not be 13.8 billion years old. It may be much less. Chapter 5. The Hubble Tension. A Sign. Something's off. This idea also speaks to another mystery, the Hubble tension. Locally, we measure one value for the expansion rate of the universe. But looking far away, using the early universe's light, we get a different number. This discrepancy has puzzled scientists for years. But if distant clocks tick more slowly, then the redshifts we observe are not purely from speed, but from time dilation. That could explain the mismatch. It's not a flaw in measurement. It's a flaw in how we model time in the cosmos. Chapter 6. Why this isn't wild speculation. This isn't magic. It's built on Einstein's principles. Time is not universal. Relativity shows us that two observers in different gravitational or motion states will disagree on how fast time is passing. Why then would we assume that time across a massively expanding universe would be constant? RTD-EU simply applies Einstein's logic further. Chapter 7. The Block Universe and Noether's Insight. There's a deeper layer here too. In the block universe, a view supported by special relativity, all moments in time exist simultaneously. Past, present and future are not flowing, they simply are. And in this model, Noether's theorem tells us that symmetry leads to conservation laws. The more symmetric the universe is across time and space, the more consistent and conserved its physics are. RTD-EU fits into this elegant picture. It restores symmetry. It removes the need for a mysterious repulsive force. And it reframes time as something that's not flowing at one rate, but something that's experienced differently, depending on your place in the cosmos. Chapter 8. A Thought Experiment. The Eternal Moment. Let me give you a final image. Picture two beings. One lives in our galaxy. The other lives in a galaxy 10 billion light-years away. Both are born, live and die in what they perceive as 100 years. But from our perspective, the distant being lived in slow motion, not because of gravity or velocity, but because of the cosmic fabric around them. Their reality, from our point of view, is slowed by the expansion of space itself. What does that mean for us? It means the universe may not be accelerating at all. We may simply be watching a cosmic mirage, a trick of time. Chapter 9. The Conclusion. The universe is not broken. We don't need to invent dark energy to fix our equations. We need to rethink time. RTD-EU is a theory grounded in relativity, symmetry and logic. And while it may not be the final answer, it opens a new path. A path where the solution to the universe's greatest mystery was hidden in plain sight. What do you think? Could time itself explain what we've misread as dark energy? Is the acceleration of the universe just a misunderstanding of the clock? Comment below and let me know your thoughts. I've linked the full theory paper in the description if you want to dive deeper. Subscribe for more explorations of time, consciousness, and the universe. And remember, sometimes the biggest truths aren't in what we discover, but in how we've chosen to measure it. Thanks for watching.